All right, 6th Hour wanted to do over on their video, so this is it right here. Okay. Hopefully I have the right microphone queued up this time, but I'm going to give you an introduction to trig identities, those of you that weren't here yesterday. If you were, you can either double dip. I've got some cards that I gave to Annie back there. You can work on those, and then everybody else can work on those cards with Annie tomorrow. But what we're going to have, sometime within the next week, we're going to have a pop quiz. And I'm going to say, here's going to be the pop quiz. It's going to say, write down the 11 basic trig identities. And so in this video, in class today, we are going to go over all 11 of the basic trig identities. So, let's talk about this. The good news is I'm going to teach it better on this video than I did in yesterday's video. No, we're getting there on the first one. Now, in terms of opposite, adjacent, hypotenuse, what was sine? Opposite over hypotenuse. Now, there was another one that related to that, though. That was just the reciprocal. That was hypotenuse over opposite. Which one of my trig identities was hypotenuse over opposite? Cosecant. So I can simply write sine as 1 over cosecant. They're just reciprocals. So cosine was adjacent over hypotenuse. Was there one of my trig functions that I could write as hypotenuse over adjacent? I think John watched the video, even though you already knew. Okay. Just the sound on that video is rough. It is. You can't hear it. All you hear is Berkeley laughing. All right, so tangent theta. Remember, tangent was opposite over adjacent. Was there one of my trig functions that was adjacent over opposite? Cotangent. Now, if you get that down, it works the other way as well. For instance, if I'm looking for cosecant, I can just take the reciprocal of sine. If I'm looking for secant, I can just take the reciprocal of cosine. And if I'm looking for the reciprocal of cotangent, I can just take the reciprocal of tangent. And that works. Look, we've already done 6 of our 11 basic identities. So, let's do a marker again. We're over halfway there. Should be a song about that. I'm not telling that joke again. I'm not telling the joke again. I regretted telling the joke.
It was so funny. That made my day.
Okay. So let's come up with some identity. If you're lucky, we'll talk about the joke. Okay, so suppose that it tells me that cosecant theta equals -7/4. I put one of these on your test. Test is looking like next Thursday, all right, towards the end of next week. What I'm going to do is I'm going to come down here, and I'm going to ask for sine. So how do I go from cosecant to sine? The reciprocals, right? Meaning that I can just do 1 over this. Why is it negative? We're not doing any negatives. Act like it's positive. 1 over 7/4. Well, dividing by a fraction is the same as multiplying by the reciprocal. So look at all I have to do to go from cosecant to sine. I just take 7/4 and I flip it upside down and it becomes 4/7. Easy enough? That's the next to last one on your test. I just ran it off. I know. think there's 15 questions on the test. That one's number 14. This one. Right here. I don't know. I don't know. I might have done 5 over 7. Can you hear it? Well, we're going. Suppose I say that cosine is going to be 3/4, and I'm asking for secant. I just have to flip it, right? So you've got to be able to recognize those as reciprocals, and you will after we do our classwork tomorrow. We do some speed dating, okay? So all of those work that way. Easy enough? I can put that on the test. It's going to be on the quiz as well. Quiz got moved back to Tuesday. Oh, there's 2 more identities that fall under quotient identities. Both of these are going to help me get my hands on tangent theta and cotangent theta. Now, tangent theta, if you remember, it's going to be opposite over adjacent, right? I'm wanting to, the whole point of today is to get off the idea of being opposite over adjacent or adjacent over hypotenuse and get off those. But what I'm going to do is I'm going to divide both the top and the bottom by hypotenuse, by the hypotenuse. And so which one of my trig functions is opposite over hypotenuse? Sine. And which one of my trig functions is adjacent over hypotenuse? Cosine. So all I need to know is that tangent is going to be sine over cosine. Yes.
Sine and cosine. You get sine to be like cosine of
Sine would be cosine times tangent. Just write that. A over H. So yeah, eventually we're going to do that. We have to prove some trig identities. So if I multiply both sides by cosine, cosine tangent would equal sine. And we'll prove that later on. It's really neat how it works. Now remember, cotangent was just the reciprocal of what? Tangent. Absolutely. Cosine over sine. Good. So let's see some examples with these. Now we might have to mix in those first 6 that we did. It'll be okay. Remember which ones we did yesterday. We can do this one. We'll say cosecant x is 25 over 7. And secant of x is 25 over 4, or 24. I'm wanting to know what tangent of x is. So tomorrow when you come in, you might have this on a note card. You're going to become a professional at this and then be able to work it out. Now, which one of my trig identities dealt with tangent? Or what was tangent on my quotient identities? Was that the cosine over sine? Sine over cosine. Okay, so let's write that down. Tangent was going to be sine over cosine. Okay. Now, they didn't tell me sine or cosine. So is there something I can do with one of these trig values to make it so it becomes sine? Reciprocal of which one? Remember, if I take the reciprocal of cosecant, it turns it back to sine. 7 over 25, yeah. Great. What about cosine? How can I get cosine from one of those values? It's the reciprocal of secant, absolutely. Now I get a lot of questions how to simplify this. First of all, you can just think the 25s cancel. You can think, well, I'll just multiply the top and the bottom by 25 because multiplying by 1 doesn't change the value of it. Either way, you're going to end up with 7 over 24. You can also do a keep, change, flip and just multiply. Dividing by a fraction is the same as multiplying by the reciprocal, and you get the 25s to cancel. So 3 different ways you can think about simplifying that all the way down. All right, let's do one that has a square root in it. Cotangent x is 2 over 5 square roots of 5, and sine is going to be the square root of 5 over 3. Again, we can use sine or we can use tangent or cotangent on this, whichever one you feel more comfortable with. I like to roll with what they give me, though. Cotangent. What was my cotangent identity? Cotangent was cosine over sine. So it's cosine over sine. They're giving me a little bit different information on here as to what I have. I know what cotangent is going to be, 2, 5 square roots of 5. I'm looking to know, I want to know what cosine is. I guess I should put that down here. Cosine x equals something. And if I plug in sine, it's going to be square root of 5 over 3. And this just turns into an algebra problem. I want to solve it for that cosine that's up here in the numerator. What is the, what's the opposite of dividing both sides by a square root of 5 over 3? Not dividing, but multiplying. So be careful with this. Here, the square root of 5s are going to cancel. And I'm left with just 2 on top. And I have 3 times 5 on bottom. That'll be 15. So cosine x is going to be 2/15. All right, let's do one more. All right, you guys work this one on your own. You get it set up. Secant x equals 5/4. And tangent x is going to equal 3/4. I want you to find sine x. Okay, so go ahead and hit, if you're watching this on the video, go ahead and hit pause, work it out, and then we'll work it out as well, and we'll see if we match answers when we come back. All right, hopefully on that you got sine x equals 3/5. Sine x equals 3/5. I had to use my reciprocal identity right here on the top and change that secant to a 4/5. And it's always going to be easier to work with sine and cosine on these than it's going to be cosecant and secant. All right, 3 more identities. Blake, you might have to remind me how I did this yesterday because it worked out really well. Oh, I started with that triangle, didn't I?
Yeah, you
Yeah. All right, so when you guys hear a Pythagorean theorem or a Pythagorean identity, what comes to mind? A squared plus b squared equals c squared, right? X squared plus y squared equals z squared. Whatever letters you use there, that is going to be my Pythagorean identity. Now, in this case, I'm not using A, B, and C. I'm using opposite, adjacent, and hypotenuse. And the way that we come up with these three Pythagorean identities is we just take turns dividing by a different side of the right triangle. For instance, I'm going to divide by the hypotenuse first. I'm going to divide everything by the hypotenuse. Well, that gives me opposite over hypotenuse. Which trig function is that? A sine, right? So sine. And we put the squared in a really weird spot when we do trigonometry. Okay? This is the same as sine of theta squared. They got tired of putting the brackets and the parentheses around it, so they just put the squared up here between the word and the theta. Okay. All right, next up, we have adjacent over hypotenuse. What happens, which trig function do I get if I take adjacent over hypotenuse? Cosine. And lastly, I have hypotenuse over hypotenuse. Anything divided by itself is 1. Okay, so this is going to be my first Pythagorean identity. That's the 9th one, yep. So next week, that's going to be the 9th identity you write down. You don't have to do all this stuff of where it comes from. You just have to be able to write down the identity. Okay, next. I'm going to divide everything by adjacent. Adjacent squared. Okay, so help me out here. Opposite over adjacent is which one of my trig identities? It's my tangent, so it's going to be tangent squared. Adjacent divided by adjacent is just going to be 1. And then I have a weird one, hypotenuse divided by adjacent. Which one's hypotenuse divided by adjacent? Which one is that? It's my secant, absolutely, yeah. Secant squared theta. You guys are still waiting on that secant joke. Okay, keep waiting. All right, this is identity number 10. Got one more. All right, the only thing we haven't divided by yet is the opposite side. So I'm going to divide everything by the opposite side squared. Well, opposite divided by opposite is just going to be 1. About adjacent divided by opposite. That's my cotangent, absolutely, yeah. And then finally, we got a weird one, hypotenuse divided by opposite. CSC, cosecant. I suddenly went to x's on this. You can act like they're thetas, x's, doesn't matter. There we go. So those 11 identities, the 6 we did on the front one, the 2 quotient ones that have to do with tangent and cotangent, and these 3, I need you to write those on a sheet of paper sometime within the next week. All right, without looking at them. You have to know them by memory. Okay? And we'll be using these for the next few months. And again, the whole idea of this is to make it so we don't have to draw this triangle anymore. We're wanting to be able to do this just with our words and stuff. And I pointed this out yesterday. If you come over here and look at the calc test from yesterday, there was a couple instances they had to use it. They had to take sine divided by cosine and call it tangent down here on the next line. Somewhere else they used it. Or maybe not. I think it was over here. Yeah, over here they had cosine divided by sine. They had to tell me it was cotangent. So this is just stuff that we have to know going into any math that's going to be pre-calc B or higher. All right, let's get some practice on these. A lot of you are going to have something to do with the Pythagorean identity tomorrow on your card. You need to know how to tackle it. So let's just start with an easy one. Cotangent theta is going to equal 2. I want to know what sine and cosine are. Now, if I get this card tomorrow, I got my fingers crossed. I'm hoping that if Mr. Lovelady gives me cotangent, that he's going to be wondering what tangent is, because all I got to do is take it and flip it, right? Unfortunately, I didn't get that. So what I want to do is I want to go back and look at my Pythagorean identities. I want to find the one Pythagorean identity that has to do with cotangent, which is
Number 8.
number 8. Okay, now I want to bring that up. I like what she said there. She said cotangent equals cosine over sine. And so it would make sense that if cosine would be 2 and sine would be 1, and I would be done with the problem, right? Unfortunately, they're hardly ever going to be that easy. And the reason why is because sine and cosine can't ever be bigger than 1. Okay? If you think about taking a right triangle and dividing its opposite side divided by the hypotenuse, that opposite side can never be bigger than the hypotenuse. So it can never be bigger than 1. Okay? So let's jump down a little bit past number 8 and get to a Pythagorean identity. Is there a Pythagorean identity that deals with cotangent? It's the last one, right? Yeah. There was one that said 1 plus cotangent squared theta equals cosecant squared theta. Now you might be looking at it, I don't really want to know what cosecant is, but cosecant is going to help me a lot more than you can maybe think about right now. So let's plug in what we know. I know 1 plus, let's see, cotangent squared. If cotangent is 2, I'm just going to square that. 1 plus 2 is, 1 plus 2 squared is going to be 5. I'm going to take the square root of it. I'm going to break a pre-cal rule right here. Whenever I take the square root of 5 for the next week, I'm just going to assume the positive. We're in the open plane. We're not going to worry about negatives right now. That brings in a bunch more rules that we're going to have to go forward with. But cosecant equals square root of 5. Now, I'm not wanting to know what cosecant is. I'm looking for sine or cosine. Can cosecant help me get sine or cosine? I can just take cosecant and flip it, and it gives me sine, right? So if I flip it, it gives me 1 over the square root of 5. Well, way to go, Caitlin. You gave me a square root on bottom. How do I fix that? Yeah, we got to rationalize it. Square root of 5 over 5. We got one of them. Now, there's 2 things that I can do in order to get my hands on this cosine right here, okay? Let's think about it. I know what sine is. I know what cotangent is. Now, Sophia, come back to you. Is there something easy I can use with cotangent that will help me with cosine and sine? All right, the 8th one, right? That's going to be that first one we tried to use. But let's see what happens when we try to go with it now. Cotangent equals cosine over sine. This one's going to be okay to use now because I'm only going to have one unknown. I know cotangent is 2. I'm looking for cosine, and I know that sine is going to be the square root of 5 over 5. Now, some of you might have been saying, well, I would have done another Pythagorean identity. I would have done sine squared plus cosine squared equals 1. You would have got the same answer, okay? I think that just using one Pythagorean identity, though, is going to be enough going forward, all right? So just multiply both sides by square root of 5 over 5, and I get 2 square roots of 5 over 5. And that is what my cosine is going to equal. Good. All right, let's do one that's a little bit harder. Ooh, I like this one. We did this one yesterday. Sine x is going to be 1/6. I'm wanting cotangent. Let's keep the same variable here. I'm wanting cotangent, and I'm wanting secant. This is where students want to make sure they put this C in this bottom one right here. Otherwise, it gets kind of awkward. So, I've got two unknowns that I'm looking for. All right? They don't get it. You guys get it? Andrew, I really want to make sure you put the C in this line right here. Otherwise, it gets awkward. All right.
Oh, I did it.
I got it. We're getting it now. All right. And I'm recording. This is great. They got it yesterday. All right. All right, now, a quotient identity is not going to help me out because I only know one thing. Whenever I only know one trig function, I'm really crossing my fingers and I'm hoping that Mr. Lovelace is asking me cosecant down here because all I have to do is flip it. He's not asking cosecant. Otherwise, I could just write 6 and I'm done. Okay? So I need to find a trig function that deals with sine. Do we have a trig function that dealt with sine? The very first one, didn't it? Or the very first Pythagorean one. So number 9. It said that sine squared plus cosine squared equals 1. Now, even as juniors and seniors, I've seen a lot of people struggle with these fractions. And if you're dealing with sine, you're going to have fractions on this. If I square 1/6, what does it give me? 1/36. I can simply square the numerator and then square the denominator. Okay, now I'm trying to solve this down for cosine. So I'm going to make it so that this 1 has a common denominator. Okay, so whenever I subtract off that 1/36, it's just 36 minus 1, which gives me 35/36. Take the square root, assume just for now that it is positive, and I get the square root of 35/6. Way to go. That didn't help me at all because I really don't want to know what cosine is. I'm looking for cotangent and secant. Huh? That's what I'm asking you. Why did we just do this? Did it help me get closer to one of them? Cotangent is going to be cosine over sine. Let's write that down over here. Cotangent is going to be cosine over sine. Okay, and we know what cosine is going to be. Square root of 35 over 6 and divided by sine is 1/6. So John's doing good there. He went ahead and got his cotangent. But I still need to get my hands on this secant. Man, only if there was something I could flip or turn upside down. Yeah, it's a multiplicative inverse of cosine. So secant x, I'm always worried about that c now. Every time I say that, is going to be just the reciprocal. Well, that puts a square root on bottom, but if we've been doing our practice problems, we should be good on cleaning that up and getting 6 square roots of 35/35. So I've got both of my answers right there. You see where this is going to take some practice? Okay, let me give you one to end today on that you can practice with We'll come in tomorrow, we'll do some speed dating, we'll get a lot more practice. When we come in next week, we're going to be ready for this first test. Okay? So let's do one more that you can practice on. Again, I'll write it up here, and then we'll hit pause, and then you can work the problem on your own. Ooh. Let's do this one. I think this is one we did yesterday. Let's do tangent theta equals 8. I want to know sine and cosine. Let's keep the same variable. Remember, it's not going to be as easy as, well, sine has to be 8 and cosine has to be 1. Sine and cosine cannot be bigger than 1. Okay? So go ahead and hit pause, and then work the problem and see if you match my answer. Here's the answers that we got in class.